Welcome, dear friends. Today we are going to learn about size reduction. The objective of this particular video is that after watching this video, the student will be able to learn what is exactly size reduction. They will be able to explain mechanism and laws governing size reduction. They can also explain the factors affecting size reduction and ultimately can explain the construction, working, advantages, disadvantages, and application of hammer mill, ball mill, fluid energy mill, edge runner mill, and end runner mill. Now, let us see what is exactly size reduction. Size reduction is defined as a process of reducing large solid unit masses into small unit masses, that is, coarse particles or fine particles. Size reduction process is also termed as comminution or diminution or pulverization. Two methods are used for size reduction, mostly precipitation and mechanical process. In precipitation method, the substance is dissolved in an appropriate solvent. It is then precipitated by addition of a solvent in which the substance is immiscible, but it is miscible with the first solvent. In mechanical process, the material is subjected to mechanical forces using grinding equipments, which includes ball mill, colloid mill, etc. What is the objective of size reduction? In the materials processing industry, size reduction or comminution is usually carried out in order to increase the surface area because in most reactions involving solid particles, the rate of reaction is directly proportional to the surface area of the particle. Okay, or we can say it is proportional to the area of contact with the second phase. Breaking a material into a very small particles in order to separate the valuable amongst the two constituents. Also, it is used to achieve intimate mixing, to dispose solid waste easily, to improve the handling characteristics, to mix solid particles more intimately. What are the advantages? First is there you get content uniformity, uniform flow, effective extraction of drugs. It can be also used for effective drying. It improves the physical stability of the product. You can also observe improved dissolution rate. There is improved rate of absorption. What is the disadvantage? There might occur drug degradation. There is poor mixing. There might occur contamination. What are the different modes of stress in size reduction? First is cutting. The material is cut by means of sharp blade. It is useful for comminution of fibrous and waxy solids. It includes cutter mill. Next is compression. In this mode, the material is crushed between the rollers by the application of pressure. Example is roller mill. Third is impact. It involves operation of hammers or bars at high speed. When a lump of material strikes the rotating hammers or the material comes across the bars, it gets split apart. This is continued until the particles are reduced to desired size. Example is hammer mill. Impact also occurs when moving particle strikes against stationary surface. Its example is fluid energy mill. Next is iteration. It involves breaking down of material by rubbing action between two surfaces. Example is fluid energy mill. Now, what are the different theories or the laws which govern size reduction? The energy requirement for particle size reduction is a function of input and output of particle size, hardness, strength, and other properties of the solids. Various theories of energy requirement are: first is Rittinger's theory, next is Kick's theory, and Bond's theory. Energy requirement. Supplied energy is used to increase the new surface area. It initiates the flaws or cracks in the particles. The rest of energy is used for falling. The particle can undergo elastic deformation due to it, also for transportation. Also, it is used for friction in between the mill and particle. It is also used for production of heat, and it is also responsible for vibration and noise. The energy required for size reduction is inversely proportional to the size raised to some power. It can be expressed as dE by dd is equal to ratio of minus e to d raised to some power, where E is the amount of energy required to produce a change, d is nothing but size of unit mass, n is constant. Integration equation can be applied, and this is the equation. If n is 1, equation 2 becomes Kick's theory. If n is 1.5, it becomes Bond's theory. If n is equivalent to 2, it becomes Rittinger's theory. Now, what is Rittinger's theory? According to this theory, the energy required for size reduction of unit mass is proportional to the new surface area produced. This is the equation for the same, where SI is initial surface area, Sn is new specific surface area, Kr is Rittinger's constant, E is amount of energy. It is mostly applicable to brittle materials undergoing fine milling. This theory ignored deformation before a fracture. Now, what is Bond's theory? This theory states that energy used in crack propagation is directly proportional to the new crack length produced. It also states that the energy used for deforming or fracturing a set of particles of equivalent shape is proportional to the change in the particle dimensions. This is the equation for same, where Kb is nothing but it is the Bond's work index. Di is initial diameter of particles and Dn is the new diameter of the particle. So Bond's work index is the work required to reduce unit weight from a theoretical infinite size to 80%, passing 100 micrometer. This theory is useful for rough mill sizing. The work index is useful for comparing efficiency of milling operations. Now let us see Kick's theory. According to Kick's theory, the energy used in deforming or fracturing a set of particles of equivalent shape is proportional to the ratio of size changes. It is expressed as, and this is the equation, where Kk is nothing but the Kick's constant. Di is diameter of particle in initial stage, and Dn is the diameter of particle, new particle. For compression of large particles, Kick's theory is useful. Let us see the summary. Rittinger's theory is seen if n is equal to 2, and it states that energy is directly proportional to new surface area formed. Bond's theory is when n is equal to 1.5, and it states that energy is used in crack propagation is directly proportional to the crack length produced. And Kick's theory is applied when n is equal to 1, and it states that energy is directly proportional to the ratio of the change in the size. So this was all about size reduction. Thank you for listening.